Okay, this is Honors Math 3, and we're in Unit 3, and we are still using just the Math 3 packet, and so since we're Honors, we're actually going to be combining worksheets 4, 5, and 6 together into one lesson because it really just blends all together. Now we're also going to do kind of a preview of worksheet 7 as well, and so this is just all one big set of notes, but this is really kind of two assignments worth. Anyway, we're doing lots of graphing of polynomial functions, and as was mentioned early in the unit, factored form is a very nice form for us to be in when we're trying to graph and figure out intercepts and all that kind of stuff with polynomial functions. And early on, we were giving things to you in factored form, but I also mentioned to you that things were not going to be factored, and we were going to have to be doing some factoring. So now there will be some problems in the assignment where the directions are just simply to factor completely. Now, remember, when we are saying factor completely, we are actually saying factor completely over the integers. So if we have to go into imaginaries, or if we have to go into radicals or something like that to factor, that's not what we're meaning by the factor completely. We're meaning factor completely over the integers. Okay, but then there's also some where we're going to be sketching, and then part of the sketch is always labeling the intercepts, because we're not just doing the in-term behavior. We're doing more than that. Okay, so now when we're not in factored form, there are a couple things that are nice, and so let me point out, and literally it's usually just a couple things, but for example, as far as the graphing goes, we can see what the first term actually is. It's a positive 9x to the fourth, so it's even degree and it's a positive lead coefficient, and so therefore this graph is high to high. So that's something that's very nice. We don't have to actually mentally multiply it out and figure out what it is. The second thing that's also very nice, when it's all multiplied out, we can actually plug in 0 for the x's to get the y-intercept. And so we can see that the y-intercept is 0, negative 25. And so when it's in standard form, this is called standard form when it's all multiplied out. So when it's in standard form, those two things are actually very nice. But anything else, you really want it in factored form. Okay, so factoring completely. Now remember, when we're factoring, we look for a greatest common factor first. Sometimes the greatest common factor is just 1. So this particular problem, the greatest common factor is just 1. Now, it is a trinomial, but it's not the type of trinomial that you guys are probably used to. Notice that the middle term exponent is half of the highest exponent, and so when that's the case, potentially it is going to factor very nicely, and it's not a guarantee that it will, but potentially it will. And so looking at this, y equals, and so all that means is if I have an x squared and an x squared, and I don't know what my coefficients are yet, but that will give me the x to the fourth, and it'll also get me the x squared out in the middle. Okay, so now multiplies to get 9. It's either 1 times 9 or 3 times 3, and you can try 3 and 3. It doesn't work. So 9x squared and 1x squared. Now 25, it's either 1 and 25 or 5 and 5, and you can try 5 and 5. 5 and 5 doesn't work. So it's 25 and 1. And so you can see that this is actually going to work out for us, because we can get, there's the 9x squared, we can get a 9x squared and a 25x squared. And so as long as the 25x squared is negative and the 9x squared is positive, then we're going to get the negative 16x squared out in the middle. Okay, so you can see where we're going with that. So we want the 25x squared negative and the 9x squared to be positive. And notice that we do get a negative 25 at the end. Okay, now factor completely. Can I do anything more with these? Well, 9x squared minus 25, yes, that's difference of squares. So 3x minus 5, 3x plus 5. Okay, now x squared plus 1. Now, if this was a minus 1, that would be difference of squares. But we don't have a sum of squares, at least not for factoring over integers. And so the reality is x squared plus 1 does not factor anymore over the integers. Okay, so as far as factoring completely over the integers, that is part A. Okay, now part B, okay, now part of the sketch, we already know part of the sketch. We know it's a high to high. We know the y-intercept. Okay, now x-intercepts, the other intercepts, those are very important, obviously. And so we find those by plugging in 0 for the y. So if we plug in 0 for the y, well, we're already in factored form. And so our zeros are, if I set 3x minus 5 equal to 0, I would get positive 5/3. If I set 3x plus 5 equal to 0, I would get negative 5/3. Okay, so positive 5/3, so plus and minus 5/3, you could write it like that. They each have multiplicity 1. Now what about x squared plus 1? It doesn't factor over the integers, but also remember the degree on this function, the original function, is a 4th degree, which means there are 4 roots, 4 zeros. Does that mean that there's 4 x-intercepts? No, not necessarily. But there are 4 roots or 4 zeros for the function. We found 2 of them so far, plus n minus 5/3. Now, x squared plus 1, if we set that equal to 0, and if we tried to solve, I could move the 1 to the other side, and I could do the square root both sides. Of course, I'm getting absolute value of x, but we can take care of it by doing the plus or minus. So x equals plus or minus the square root of negative 1, which we know is plus and minus I. So as far as the zeros, the roots, we have all 4 roots. How many distinct x-intercepts do we have? We have 2. Because x-intercepts must be real. So the only x-intercepts we have are the positive 5/3 and the negative 5/3. Okay, so I think we're ready to sketch. X-intercepts of plus n minus 5/3, which is positive 1 2/3 and negative 1 2/3. Okay, it's a high to high. The y-intercept is negative 25, and the multiplicity on each one of those is positive 1, so or is just 1, and so it starts high and it ends high and it goes through. And so really our sketch is just doing something like this. It's kind of like a parabola. Sorry, I missed my point. Didn't do a very good job drawing that there. Try one more time. Okay, and so label the intercepts. This one is our negative 5/3, positive 5/3, and our y-intercept is negative 25. And that's full credit graph there. Okay. So, moving on. Problem number 2. Similar directions. We've got the factor completely. Okay, so let's point out some things. It's already in standard form. It's all multiplied out. I notice it's positive 2x to the 5th, so this is a low to high. Okay, if I plug in 0 for all the x's, I get y-intercept of 0. In other words, 0, 0. So one of the x-intercepts is going to be 0, and the y-intercept is 0. Okay, now factoring completely. What do we look for first every single time? We always look for a GCF first. What's the GCF? Well, there looks like there's a GCF of x squared. Okay, so y equals x squared, and that leaves 2x to the 3rd plus 3x squared minus 18x minus 27. Okay, now, is there more that we can factor? Well, look at the 4 terms that are in there. 4 terms, we usually look at grouping as a possibility. So, can we do grouping? Well, typically when we're doing grouping, we look at the first 2 terms. Is there GCF for the first 2 terms? Yeah. GCF of x squared. That would leave behind a 2x plus 3. GCF for the last 2 terms, they're both negative, so, negative something. And it looks like 9 goes into both of those. So 9, and so negative 9 times 2x, and negative 9 times positive 3. Okay, and so okay, now there is a GCF of 2x plus 3, so we'll bring that out to go with the x squared. So y equals x squared times 2x plus 3. And what's left behind? X squared minus 9. Well, x squared minus 9, that factors as difference of squares. So y equals x squared times 2x plus 3 times x minus 3 times x plus 3. Okay, so there's the factored completely. Okay, now some of the homework problems that we have, it's just factoring. It doesn't have y equals or f of x equals. It's just factoring. But I'm just kind of putting it together with the graphing part that we're going to have to do as well. So the zeros, the roots. So if we plug in 0 for y, we're in factored form now. We've got x squared. Can x squared equal 0? Yeah. If x is 0, and it happens twice, so the multiplicity is 2, can 2x plus 3 equal 0? Yeah. You set it equal to 0, subtract 3, divide by 2, so negative 3 halves. And what about the x minus 3 and the x plus 3? Well, plus and minus 3. Okay, so now this problem is a 5th degree, and so therefore there must be 5 zeros, 5 roots. Have we accounted for them all? Well, 0 counts twice, so 1, 2 for 0, 3, 4, 5. We've got all 5 roots. How many distinct x-intercepts? Well, different. How many different x-intercepts? 0 is 1, negative 3 halves, positive 3, negative 3. So there's 4 distinct x-intercepts. So a total of 5 zeros or 5 roots, but there's only 4 different x-intercepts. Okay, I think we're ready to sketch now. Okay, so we've got 0, I've got -3/2 and -3 out to the left, and +3 out to the right. And this is a low to high, so out to the left a low mark, out to the right a high mark. Okay, now, do any of them bounce? Remember, even multiplicities bounce, so bounces at 0. All the others go through. Odd multiplicities go through, even multiplicities bounce. So the only one that bounces is at x equals 0. So if I start low, it goes through, and then bounces at 0, and then finishes high because it goes through that last one. Okay, I think I'm ready to go ahead and do my sketch now. So starts low, goes through, bounces, and goes through and finishes high. Okay, so when we try to do a smooth curve, just don't do corners. I mean, like I said, I'm not expecting perfect artistry here, but on the other hand, don't give me corners. Okay, so this was -3 out here. This one was -3/2. This was 0, which is an x-intercept and a y-intercept. And this one is 3. And so that's a full credit graph right there. Okay. Okay, now here's the extra part. Here's like a preview going into worksheet 7, and we're getting closer to honor stuff for this unit. Okay, now sometimes we need to be able to divide with polynomials. Okay, you've learned when you were younger how to divide with numbers, and so we're going to learn how to divide with polynomials today. Okay, and we're only doing long division today, so just in case any of you know anything about any other type of division, all of our division is with long division today. Now, come back next class, and we're going to teach you another way to be able to do some division, which is shorter and nicer to do. Okay, so 6x to the 5th minus 11x to the 4th minus 2x to the 3rd minus x squared plus 15x minus 9 divided by 3x minus 4. Okay, so we're doing long division, which when we do long division, you know, it's like we need the long division, whatever that thing is called. You know, I really actually don't know what that thing is called. I've talked to a lot of people, and they really don't know what that thing is called either. But maybe it's the long division house, I don't know. Which one goes on the outside? Well, the one that you're dividing by. So we're dividing by 3x minus 4. So 3x minus 4 goes on the outside. And then the other stuff goes on the inside of the house. Now make sure it's in descending power. So the highest power needs to be on the left, and it needs to descend as you go to the right. So 6x to the 5th. And if it happens to skip a power, you might put in a placeholder. You might put in, like if it skipped an x to the 4th, maybe you'd say plus 0x to the 4th or something like that. But you don't have to with long division. So, but just make sure it's definitely in descending powers of x on the inside here and on the outside as well. Minus 11x to the 4th minus 2x to the 3rd minus x squared plus 15x minus 9. Okay, so we're just kind of learning the process of long division here on this one, and then we got one more problem after this where we're going to apply it. Okay, now a couple different ways. One way you could look at it, you could say, okay, 3x goes into 6x to the 5th how many times? But I think the safer way to do it is to say what, pointing here on top, what times 3x? What times 3x gives me 6x to the 5th? What times 3x gives me 6x to the 5th? Well, 2x to the 4th. And by the way, you don't really have to put this lining it up with anything in particular up top. Just kind of start more toward the left side here where you put in it. So 2x to the fourth times 3x is 6x to the fifth. Make sure it's exactly what it's supposed to be, otherwise it's not going to be working anyway. But now we have to do 2x to the fourth times whatever else is out there too. So 2x to the fourth times negative 4, which is negative 8x to the fourth. Okay, now it's probably been a while since you've done some long division. So right now I'm going to remind you that we are actually subtracting. And I think it's a very, very extremely important idea to have an alternate color that's very visible right now, because when mistakes are made with long division, it usually happens right here where we're subtracting, because we actually have to distribute the negative. And if you have an alternate color that's very visible, you'll see if you distributed the negative or not. Okay, so the first terms have got to cancel. If they're not canceling, something's wrong. We've made a mistake. We got to fix it right there immediately. Okay, secondly, negative 11x to the fourth plus, because we distributed the negative, plus 8x to the fourth is negative 3x to the fourth. Okay, bring down the next term, and we do the process again. Okay, and I'm going to change colors just so you can kind of see the difference here. What times 3x gives me negative 3x to the fourth? What times 3x gives me negative 3x to the fourth? Well, negative 1x to the third. So negative 1x to the third times 3x is negative 3x to the fourth. And then you got to multiply it times whatever else is out there. So negative x to the third times negative 4 is positive 4x to the third. And now we're going to subtract. So go get that obviously different color now and distribute a negative. Okay, so first terms always eliminate, or something is desperately wrong. But negative 2x to the third minus 4x to the third is negative 6x to the third. Okay, bring down the next term, minus x squared. And just so that we can continue to kind of see what's going on, I'm gonna keep a different color going again. Okay, so what times 3x gives me negative 6x to the third? What times 3x gives me negative 6x to the third? Well, negative 2x squared. So negative 2x squared times 3x is negative 6x to the third. Negative 2x squared times negative 4 is positive 8x squared. And I'm going to subtract, which means I need my alternate color so I can distribute a negative that I can see. And then now I'm going to combine those like terms, so the first terms eliminate, and then I'm left with negative 9x squared. And bring down the next term, plus 15x. By the way, not all problems are this long. I made this one kind of long just so we can really see the process very well. What times 3x gives me negative 9x squared? Well, negative 3x. So negative 3x times 3x is negative 9x squared. And negative 3x times negative 4 is positive 12x. And we're subtracting, so grab that obviously alternate color. And combine the like terms, the first terms eliminate, and I have, grabbing my other color, or I was going to do this same color here. Okay, so we've got 3x, and bring down the next term, which the next term is negative 9. So by the way, we brought down our last term, so this is going to be our last step here anyway. So what times 3x, what times 3x is 3x? Well, positive 1. Okay, so plus 1. Okay, so 1 times 3x is 3x, and 1 times negative 4 is negative 4. And grab our alternate color and distribute that negative. Okay, first terms eliminate, and I'm left with negative 5. Okay. Now, by the way, I know I'm done because 3x does not go into negative 5. So what is negative 5? Negative 5 is the remainder. Okay, now when there is a remainder, as opposed to like getting 0 at the last step, having a remainder of 0, which means that there's technically no remainder. So when there is a remainder, it means that, that what you were dividing by is not a factor. Okay, so therefore 3x minus 4 is not a factor of the thing we were dividing into, 6x to the 5th minus 11x to the 4th plus, all that big long polynomial. So if there is a remainder, as opposed to getting 0 here on this last step, anytime there is a remainder that's not, that's not 0, technically 0 is not a remainder, but anytime there's a remainder, then whatever you're dividing by is not a factor. On the other hand, if you get 0 on this last step and you've done everything correctly, then whatever you're dividing by is a factor. Okay, so now what's the answer to the problem? Well, the answer to the problem is all this stuff here along the top, plus the remainder, which, by the way, what was the remainder? The remainder was negative 5, over whatever you were dividing by. What were we dividing by? 3x minus 4. Okay, and so technically this is the answer to the division problem. So that's the answer to the division problem right there. Now some of you might be saying, well, could I bring the negative out in front and instead of having a plus, you could have the minus out? Yeah, technically you could. It's really the same thing. But typically when you have a remainder, you say plus whatever the remainder is over whatever you're dividing by. Okay, now long division is a tool. We need to be good at it. So we need to practice one more problem. And I know that these notes are not short, but really these are 2 sets of notes. Okay, so last problem. So we've got f of x equals 2x to the 4th minus x to the 3rd minus 35x squared minus 2x plus 120. And the directions are essentially kind of what we were doing for the first 2 problems, factor completely. But if we look at this f of x, does that factor in any way that we've been using so far? I mean, is there a GCF besides 1? No. It's like, is it difference of squares? Some are difference of cubes? Is it a trinomial? Is it grouping? It's none of those, is it? Okay, so why did I teach you guys long division? Because sometimes we have to factor using division. So notice that I did give you some extra information here. And it says if x plus 3 is a factor of f of x. Okay, so now they're not asking you if that's true. They're saying this is true. So how can we take advantage of that? Okay, well, we can do division. Okay, and we're going to get a remainder of 0 as long as we do it correctly because they promised us that x plus 3 is a factor. Okay, so we're going to set up our division. And I know some of you guys are going, well, how does that help us? I will show you how it helps us. So x plus 3 into 2x to the 4th minus x cubed minus 35x squared minus 2x plus 120. Now we've done this before already, so I'm going to go faster. Have your alternate color ready to go. Okay, so here we go. What times x gives me 2x to the 4th? Well, 2x to the 3rd. So 2x to the 3rd times x is 2x to the 4th. 2x to the 3rd times 3 is plus 6x to the 3rd. And we're going to subtract. So distribute the negative. Okay, and we get, I'm not going to be changing colors the whole time here other than my alternate color. First terms eliminate, and I get negative 7x to the third. I'm going to bring down the next term, negative 35x squared. Okay, and so what times x gives me 7x to the third? Well, negative 7x squared. So negative 7x squared times x is negative 7x to the third. Negative 7x squared times 3 is negative 21x squared. And I'm going to subtract, so I'm grabbing my alternate color and distributing a negative. Okay, combining like terms, the first terms always eliminate. I've got negative 14x squared. By the way, don't just assume the first terms eliminate. Make sure that they actually do, because otherwise there's a mistake. Bring down the next term, minus 2x. Okay, what times x gives me negative 14x squared, so negative 14x. I get negative 14x squared, and I get minus 42x. And I'm going to distribute a negative. Okay, and so we get 40x, and I bring down my last term of plus 120, and we're going to see right now whether we've done a good job or not, because we should get 0 at the end if we've done everything correctly. What times x gives me 40x? Positive 40. 40 times x is 40x, and plus 120, and distribute a negative, and hallelujah, we got 0 right here. We got no remainder. Okay, therefore x plus 3 is a factor of f of x. Now, we already knew that because they told us if x plus 3 is a factor of f of x. So all we know, all we have so far right now is we just showed that it's true. Now, this is the part where I know you guys are saying, how in the world does this help us? Okay, we've started the factoring process. So f of x is x plus 3, because x plus 3 is a factor, times our answer to the division problem. So 2x to the third minus 7x squared minus 14x plus 40. Okay? So now we've done one step of the factoring. We've reduced the polynomial by 1 degree. Now look at the remaining polynomial. There's only 4 terms. Can we factor by grouping? Sometimes all we need is just one factor to help us finish factoring the rest of the problem. Now, if I look at the rest of the problem, it's still, this one, we would have trouble grouping this one. Okay, and so, okay, now, I did this on purpose, but I would have given you an extra factor, okay, but I did this on purpose just so you can actually see what's going on. So if x plus 3 is a factor of x, and so I'm going to give you one more. So sometimes they might actually give you more than one factor. So, and x minus 4, I think is the other, yeah, x minus 4 is also a factor. Okay, so I did that on purpose only to give you the one factor at first, just to point out that sometimes all you need is one factor, and then we look and we might be able to look at it and say, oh look, we might be able to actually finish it without getting another hint. But this particular problem we needed to get 2 hints. So we got the x plus 3. Now we're partially factored, and so I know that x minus 4 is a factor, so it divides evenly into f, but I don't want to divide it into f. I want to divide it into my reduced equation, because if it divides into f, that means it's going to divide into this part as well. So that's what we're going to do. We're going to do x minus 4 into 2x to the third minus 7x squared minus 14x plus 40. Okay, so here we go. We already know the process. What times x gives me 2x to the third? Well, 2x squared. I don't think I want to use that color. Sorry, eraser. Okay, so 2x squared. 2x squared times x is 2x to the third. 2x squared times negative 4 is negative 8x squared. Alternate color, distribute a negative. First terms are gone. I am left with x squared minus 14x. Okay, what times x gives, oh, well, just plus x. X times x is x squared. X times negative 4 is negative 4x. Distribute a negative, and we get negative 10x. And bring down the last term. What times x gives me negative 10x? Well, negative 10. Negative 10 times x is negative 10x, and negative 10 times negative 4 is positive 40. And you can see that when I distribute my negative, we will get 0 here at the end, which is good because we were told that x plus 3 and x minus 4 are factors. Now, by the way, some of you, I'm sure, are asking, well, what if you had told me both at the very beginning, and I did x minus 4 first and x plus 3 second? It would still work. It's just, the work would look a little bit different, but it would still work. So you could do them in either order. Now, what are we left with? We are left with a reduced equation because now we have factored a little bit more. I'm running a little bit short of space here, but f of x factors as x plus 3, but it also has a factor of x minus 4. And what's left behind? The 2x squared plus x minus 10. Okay, now, does the 2x squared plus x minus 10, does that factor again? It sure looks like it does. Now it's just a trinomial, so it looks like we can probably just finish it off. 2x, 1x, probably 5 and 2, which means the 2's over here, the 5's there. I think I want the 5 positive and the 2 negative. Yeah. So here is the fully factored form for f of x. Okay, so long division, sometimes we need long division to be able to finish factoring these things. Okay, so here's f of x all factored. I like putting the 2x plus 5 out in front myself, but you don't have to. I mean, you could just leave it in the order that we had it before. By the way, remember when we were not factored, it was a positive 2x to the fourth. So this is a high to high. Okay, the y-intercept is 0, 120. We can see the zeros, the roots. If I plug in 0 for f of x, if I set 2x plus 5 equal to 0, I get negative 5 halves. And then I get 2, then I get negative 3, and I get positive 4. So I have 4 roots, 4 zeros. My degree was 4, so that's all of them. And it just so happens that they're all different and they're all real, so therefore I have 4 x-intercepts as well. So as far as sketching this, we've got 4 out to the right, and there's also a positive 2 there, and we've got negative 3 out to the left, and also a negative 5 halves. And this is a high to high, and they're all multiplicity 1, so they all go through. So starts high, goes through, goes through, goes through, goes through, ends high. label things, -3, -5/2, +2, +4, and what was my y-intercept? 120.